All right. So I said we'd talk about BigQuery for a bit. So Google BigQuery is maybe the most significant, at least from my experience, like in terms of like doing data science work, the most significant product we have to kind of scale up and do things at a much higher level than certainly I had before in my 10 plus years working in sports analytics. So what is it? It's our enterprise data warehouse for analytics, gigabyte to petabyte scale storage and queries. That's not a typo. You can store terabyte, up to petabytes of data and query them. Essentially, and I should have mentioned this earlier, a lot of these products are based on the infrastructure that Google developed internally. So Google Cloud is essentially a bunch of products that we use to power Google Search and YouTube, but now available for other other customers basically to run. So we had the internal version of this when I was an internal data scientist at Google. We used this a ton. I wrote queries on the level I never could have thought was possible, and now this is kind of available more generally. We have a few other things too with real-time insights from streaming data, machine learning, and a BI engine thing that allows for sort of dashboarding and reporting as well. All right, so that's a great slide, but you guys want to talk about sports, and so do I. So we have an example of player tracking data. So some of you have worked in the NBA, and this will be very familiar. Others, this might be a little new. So there's player tracking data from what used to be SportView, now Second Spectrum, which we have covering the previous 6 seasons, so not this season, but so it's been available for 7 for the whole league. We had it for about 6, and this is I'm glossing over this entirely difficult thing where we got it into a BigQuery table thanks to Ramsey. But let's say you have it in a table in BigQuery. So you have one row of player tracking data. So what does one row of player tracking data indicate? If you look on the bottom right, that table, it's basically some player ID, some game, and then you have a frame. So this is like the first frame of the game, and then you have XY coordinates for every player. So that's the 10 players who are on the court at the beginning of the game. So by itself, that just tells you dots, and in reality, that isn't that useful. You need to do stuff to put the dots together. So I'm not bringing news to anyone here. A lot of people have worked with tracking data, and that's what you work on. But this is a table that has 7 billion rows, right? So you see top right, and is 1.66 terabytes. So if you have this size of data, many of the traditional methods you might use, pull something into R, pull it into Python, however you go about it, not going to work. I shouldn't say not going to work. There's all the ways to make that work, but probably not the way you want it to work. So what can you do? You can analyze it in BigQuery. So BigQuery, again, is SQL-based, but has a ton of power beyond what at least I had known about from other SQL things, and you'd start doing more in SQL than before, than I would before. So this is a quick example. The question is not meant to be sort of exhaustive or something like groundbreaking, but it is the type of question you might think about asking with tracking data. So let's say we're going to go across all 7 seasons of data. I guess I should say 6 here, where there's 7 billion rows, and we're going to say who is closest to each other, 2 players across the entire league. Okay. So how would we go about it? So some of you know SQL, and you can look at the code on the right, and if you don't, just look at the text on the left. This isn't, again, groundbreaking, but it gets the idea of what you might do with BigQuery. So on each frame, so on each, and I should have mentioned this, 25 times a second in the NBA. Each frame, you look at one player and another player, and then you join them to basically say, let's match them up. Then you take their X and Y coordinates and calculate the distance. So this is just using the distance formula you might have learned in geometry class. And then from there, you have how close everyone was to everyone else on every frame, but you want to aggregate. So this is now where you aggregate across basically all player pairs. And in this case, I do no grouping on game or season. We just take the whole thing. And we measure 2 things that have been highlighted on the right, which is the percent of time they spend within 5 feet of each other, just as a proxy for being close, and then the average separation for each pair of players across frames. And then you can see how we calculate that on the right. We filter. We don't want to just calculate hey, these guys share the court for a minute. And since we're going across 6 seasons, we can do 250-minute filter, and then we'll sort by that percent time. So I'm going to actually try to run this live. This is always dangerous. Gave you the answer. But let's see if we can do it. This is always dangerous to do a live demo, but I'm going to give it a shot. If anyone wants to chime out, how long do you think this query will take to run? Yeah, so I'm going to start this query and you have to stay until it runs. So if days is true, then you're going to miss a lot. So let's see. This takes me into the BigQuery console. Maybe it's going to run. No, okay. So we'll let this. This is what happens. Try to help out your teammates. So I got to switch amongst my various Google Cloud projects here. All right. So query failed. So obviously that had to happen the first time, so I could show you what it's really like. That was cached. All right, we'll work on this. This is the real answer. So it took 1 minute and 3 seconds. So let's keep that in mind. So that just processed 672 gigabytes of data. The SQL was, I mean, I'm not trying to like demean it, but it's not super complicated. And we just calculated everyone versus everyone across the almost history of tracking data. From the basketball standpoint, the interesting point is the answer is Andre Drummond and Hassan Whiteside. And then more interestingly, the answer is all centers who don't stretch the floor. And it kind of makes sense because, you know, we didn't filter here for offense, defense, or anything like that. We just talked about who kind of stands next to each other. These guys aren't chasing each other around the perimeter. They're kind of posted up on one side of the court or the other, or at least down on the block. So this makes some sense and, you know, gets you the type of analysis you can do very, very quickly using BigQuery. So hopefully this highlights a thing. I'm sorry the live demo didn't work. I probably should have tested it out more, but hopefully you'll get the idea. So yeah, that's all I had on BigQuery. I have 2 minutes if people have questions. Going once. Yeah, so that's a good question. Yeah, I also should have mentioned at the beginning, I don't work on the sales team, so I don't, yeah, we have different pricing. So that there's like sort of, if you have a huge organization where you'd pay for a slot and it would just be a flat rate. It wouldn't matter how many queries, but there is a cost per gigabyte. I think it would be on the order of cents to dollars, not like, hey, you ran that query and you're fired. So yeah. There are queries that other organizations who have much bigger data that do, where you'd have to really think about, like, before you hit submit, like, think about what you're doing. That one's still within range. You wouldn't want to run it every second, but yeah, good question. Sorry, the question was how much it costs. I realized that people might not hear Dan.